All right, we're looking at 4.2. Here, we're going to use the properties of logarithms to expand and condense logarithmic expressions. All right, so no, this is terrible. I don't like the way. Man, I wrote in pen. That's condense. 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 Make something small. Like put it into a smaller thing. All right, so let's start off. We need to know the properties of logarithms in order to be able to expand and condense. All right, so our properties of logarithms, properties of logs. Woo! I don't know why I put a big exclamation point there. We'll just box it. How about that? All right, so the first one that we have is the addition multiplication law. All right, so it says if I have the log of something, and here we're going to use base 10, right? There's no base, but it's understood to be base 10. And I add it with another logarithm with a different argument. Right here, base 10, log base 10 of A plus log base 10 of B. All right, so I have the same base. It's muy importante that we note that these all have the same base. So note, all have same base. All right. So the log of A plus the log of B is going to be the log of A times B. And this goes into the argument. Okay. Now we have the subtraction division law property. So we have log of A minus log of B. And that gives us log of A over B, like so. And then finally we have our exponential property. It says the log of A raised to the x power. Now the exponent comes out front and it becomes x times the log of A. All right, so let's go through a few examples. Right, we want to expand and condense. So for the first one, we're going to expand the following. All right, those are going to be the directions. It's going to say expand the following, right? The first one we're going to see, let's try this. Log of 6 times 11. Now, I could rewrite that as log of 66, but that's kind of boring. It tells me to expand this, so I'm going to make this bigger. All right, so inside my argument, I have 6 times 11. And when I look up here, which of these three does this look the most like? It looks the most like the log of A times B. And so in that instance, I'm going to expand this and make it bigger. I'm going to make the log of A plus log of B. Well, A in this instance is 6, B is 11, so here I get log of 6 plus the log of 11. Not bad. Not bad. All right, I'm going to expand a couple more, and you're going to find, I want you to pay attention to the subtleties, the differences between these two here. All right, let's take a look. We have the log of 6 over 5 raised to the 6th power. All right, so it looks like I have two things happening here, and that's true, I do. And I'm going to have to take 2 steps in order to solve this one. All right, so this is our example 1. This is example 2. I just want to make sure that we know this is different. All right, so when I look at the log of 6 over 5 raised to the 6th power, well, the first thing I'm going to take a look at is, hey, I have a fraction here, right? So I should be able to expand these out using subtraction. But the problem is that I have this 6, this exponent being attached to the whole thing, right? Since the exponent's on the outside, I'm going to handle him first, log of A raised to the x power. Well, notice here that the x came out front and is multiplied here. So I'm going to take that 6 and move it out front, and I get 6 times the log of 6 over 5. And now I can expand the log of 6 over 5. But notice it's the log 6 times all of this. So I'll end up with 6 times, and I'm going to use brackets here instead of parentheses, but they have the same meaning. So the log of 6 minus the log of 5, right? So the log of 6 minus the log of 5. Right? Because I had an a over b in the subtraction there. And essentially I could distribute this through, so I'd end up with 6 log of 6 minus 6 log of 5. We have time for one more of these. Let's do one more expansion, and then I have plenty of time to condense. So let's do one more example, and I'm going to do him over here. What happens with the log of x over y to the 6th power? Okay, so now I have a fraction, and there's no exponent. My exponent's inside this fraction. So my first step here in this instance is to handle the division, right? Handle to the division. So I'll end up with the log of x minus the log of y to the 6th. And the log of this guy minus the log of this guy. Well, now I have that exponent. So then I could take advantage of my exponential law, and that 6 is going to come out front to here. Not all the way in front of the x, right? The x didn't have the 6th power. Right, just the y. So then I end up with the log of x minus 6 log of y. And that'd be my final answer. All right, let's take a look at what happens when we try and condense. All right, so the directions are going to be pretty simple. Condense the following. All right, so let's take a look at our first example here. We got the log of 3 minus log of 8. And here we're going to condense. So I'm going to take it from 2 logarithms down to 1 logarithm. And what's happening between these 2 logs is subtraction. Right, and in subtraction, then I'm going to, with the property says when I'm subtracting these guys, as long as I have the same base, when I subtract them, then I'm going to have the first argument divided by the second argument. So this is when we end up with the log of 3 over 8. Nice and easy. All right, let's try another one. Log of 2 plus the log of 11 plus the log of 7. All right, I'm adding here. So I'm going to go one at a time just to show you what to do. But, I mean, if you're kind of with it, you understand you could do this all at once. All right, so here I'm going to go these 2 first, and I get the log, and we're adding, so that means I multiply my arguments. 2 times 11 plus the log of 7. And since I'm adding, then I'm going to multiply my arguments. So then I get the log of 2 times 11 times 7. You could do all the work to find out what that is. I have no idea off the top of my head what 22 times 7 is. I'm sure we could figure it out. All right, so that's condensing. All right, I took 3 logarithms, and I condensed all 3 of these logarithms down into 1 logarithm. All right, let's try one more example. Last example here. What happens if I have the natural log of x minus 4 times the natural log of y? Well, I see I have that division here, right? So that division is, I definitely am going to, or the subtraction, so I'm going to end up dividing these guys. But before I can do that, I have this number, this multiplier in front. Now remember, this is part of your exponential law. So that 4 now becomes the exponent of y. I have the natural log of x minus the natural log of y to the 4th. And now I can do my division. So I'll end up with the natural log of x over y to the 4th. And we're done.